Hello, statistics student. This video is for chapter 9.1, 3 and 4, Basic of Hypothesis Testing, part 3. So we're going to do 3 examples on how to go through the whole hypothesis test, excluding the calculation part, which we'll do in the next lesson. So example 1 would be you want to test that the claim of a temperature of a adult body temperature of an adult is less than 98.6. You want to use a significant level alpha is 0.05. We collect a sample, of course, and then we have some number here. But without going through the details, we find that using the calculator, they give us a test statistics of negative 2.56 t, negative 2.56, and a p-value of 0.0072. So this is basically what you will see when you are doing a hypothesis test. Except in reality, you would have to sample and you have to calculate this too, which we'll cover later. But our main focus is how to write the claim and how to make conclusion. Okay, so the first is to write the claim. So you see that the claim is body temperature is less than 98.6. So I think when they claim that, I think they mean the mean body temperature. Maybe I should fix it. So the average is 98. Is less than that. You want to claim that because I think 98.6 is the established one. So you write down your claim, just translate it as 98.6, and you write it in x0 being equal to 98.6. And then your alternative would be less than, where your claim is actually in here. So after you do this test, because your alternative hypothesis is the claim, you can, if you see a rare event, you can support it, right? So you're wanting to see a rare event of rejecting this. So now see, do I have a rare event? So when we do calculation, we would look at some parameter first. So what kind of tests am I doing? The types of tests is less than, so it's called a left tail test. It's called a left tail test. If your X1, your alternative hypothesis pointing to the left direction, that means you are looking at things that would be very surprised if it is really low number. Okay, you're claiming that it is low, so you want to have a sample that is low to support your claim. And then because you were testing meal, so and sigma is not given, so we use t distribution. So x bar is normally distributed, but the tick mark are done by t. And the types of tests is left tail test, and you also would write down alpha. In this case, alpha is given as 0.05. So that's the second part. The third part is interpret the meaning of test statistics and p-value that they calculated for you. So the meaning is you have two number given. T is negative 2.56. This just means that where is your sample? Your sample is 2.56 times of tick mark below 98.6 of your assumption. P-value is 0.0071. That means there is a less than 1% chance, as a matter of fact, 0.71% chance that you will observe this sample, or worse, if the mean is actually 98.6. That means all these are based on x0 is true. If x0 is true, I would have these that I see. Do you see that this is quite rare? Now, you observe the sample is because your assumption maybe is wrong, right? So conclusion about x0, since p-value of 0.071 is less than 0.05, we say that it is a rare event, so we reject 0 based on rare event rule, and we say that the sample is significant. And p-value is less than, because of p-value less than alpha, we use sufficient evidence. You have a significant event, you say there is some sufficient evidence. And then let's continue. The second example. The second example. Oh, I didn't do an example about the claim. right? So I think I missed the example about the claim. So what should the claim be? Because I have a low p-value and then the claim is x0. So the conclusion about the claim would be what? There is sufficient evidence to support the claim. The p-value tells you that you should say there is sufficient evidence. The fact that your claim is X, the alternative, you would use the word support because rare event rule is rejecting this, right? So earlier we say we reject 0. If you reject this, which is not the claim, then you will support the claim. So this is the claim conclusion. Yeah, I forgot to, I don't know where it goes. So let's do the second example. Make it a little larger first. And also get the pencil ready. Okay, so the second example is about claim of proportion, right? Percentage. We want to claim that the proportion of red M&M is greater than 10%. And then we have a sample that gives us test statistics of 1.91 and a p-value of 0.0566. So again, we go through the process of writing the claim, determining the distribution, the types of tests, and then the most important thing is to interpret the meaning of test statistics and p-value and also make conclusion. Okay, so the claim is greater than 10%. So we write claim P greater than 0.1. The null hypothesis has to be always equal, right? 0.1. And now our alternative hypothesis is greater. So basically the claim is in the alternative hypothesis. The second part is to write down what we know about p hat. P hat is normally distributed, so we use a normal distribution. And because the arrows in H1 points to the right side, so we expect a big number to be surprising. So we call this the right tail test. And then what do we also wanted to say? Oh, we want to write down alpha. So alpha is it given? Oh, alpha is 0.05. I should a typo here. It should be 0.05. So which is what is being significant. So let's see a test statistics, and then the next thing is look at our sample and to check if it is actually rare. So look at the test statistic of 1.91. It means that the sample proportion is 1.91 times above the mean of x0 of 0.1. So it's if you look at how the p-hat distribute, this is 1.91 above 0.1. 1.91 times of the standard deviation above it. P-value of 0.0566 means that there is a 5.66% chance to obtain this sample or worse if p equal to 0.1 is true. If our null hypothesis is true, getting this sample is 5.66%. Now 5.66% is actually quite low, but if I compare it with my alpha of 0.05, it is greater than that, so it's just over the critic, like the threshold. So we cannot say that it is rare. We say, oh, it's failed to reject 0. I cannot reject 0. The sample is not significant. So if you don't have a significant sample, you would say no sufficient evidence. You cannot reject anything, right? But my claim is actually in here. I'm not in X0, so you would use not sufficient evidence to support the claim. Okay, let's go through the conclusion. My claim is the alternative, and I failed to reject 0, so I use box number 4, not sufficient evidence to support the claim. So you can use that to make your conclusion, the flow chart to make it, which is box number 4. Oh, it should be this one. No, it would be this one. It should be, so there's not sufficient. Yeah, for not sufficient, it's greater than. Yeah, box number 4. So you can use either way. In either cases, you would say there is not sufficient evidence to support the claim. So that means your sample does not support you that it is greater than 10%. It could still be less than or equal to 10%, or according to the null hypothesis, extreme case is just 10%. Okay, the last example. I want to test the claim that IQ score of college student has a mean equal to 104. And I know that the standard deviation of IQ score is 15. So this is sigma, it's a population standard deviation. And then also a sample of IQ score from 40 college students gave a test statistic of 0.84 and a p-value of 0.1995. And I want to use 0.05 to test the claim. So again, we do these 4 things: write the claim and the hypothesis to practice. Think about, if I'm testing the mean, what kind of distribution do I use, and what types of hypothesis tests, and also what is alpha. The next things is the meaning of test statistics and p-value, and also make conclusion about X0 and about the claim. So the first is about the claim. So see, my claim is the mean IQ score. I should actually say mean IQ score. Oh, has a mean equal to 104. So I should say just equal to 104. So this is actually my claim. And then in X0, I would use, this is a typo also. It should be use mu equal to 104. So the alternative hypothesis should be mu not equal to, because this has to be opposite, right? The claim now is here. When I do this hypothesis test, I would use the statement of reject the claim. Reject the claim, reject the null hypothesis. The second thing is look at what we are testing. We're testing mu, and sigma is known, so we use normal distribution. And because the alternative hypothesis has the form of not equal, so the hypothesis test is called a two-tailed test. So let's look at our test statistics and p-value. Test statistics is 0.8432. Is it right? Yeah, 0.84 means the sample is 0.84 times of standard deviation from 104 of the null hypothesis. So you can see that it's not far away from 104. It's aligned with the null hypothesis. The p-value of 0.1995 means there is a 19% chance of getting such sample if the mean is actually 104. So what do you suspect the conclusion would be? So you would say about X0, p-value 0.1995 is greater than 0.1. Is our a significant value 0.1? Let's see. I didn't realize it is. Oh, I say 0.05. Yeah, I say 0.05. But in either case, yeah, I think there is another typo here. So this is 0.05. I should not compare with 0.1, right? This is the alpha. So the sample is not a rare event. So we would say we fail to reject X0, cannot reject 0. Sample is not significant. This is another typo. So because p-value is greater than alpha, what wording should I use in my writing of the claim? I should say not sufficient evidence. And because the claim is X0, I should use the word reject, right? I should use the word rejects. I should use the statement of reject. So you would say there is not sufficient evidence to reject the claim that it is IQ. So you cannot reject the claim. So look carefully. You cannot reject it. That means the IQ score is still 104. Okay, so remember we have failed to reject 0, and then let's look at the flow chart. We have X0 is the claim because it is equal, and then we fail to reject 0, so we go this path. So the wording that we write is there's not sufficient evidence to reject the claim. You cannot reject, not sufficient to reject. So this is the flow chart is box number 2. So that's all for the process. I hope you understand how we can write a final conclusion about the claim. That's the difficult part. And also establishing the write a claim properly, because if this is wrong, you would have a wrong conclusion. The middle part is about calculation, and we will cover it in 9.5 part 1 and 9.5 part 2 in the next lesson.